If the vertical axis is position, does either child ever change direction? Well, let's think about this for a minute. We have a person moving in a hallway. We can locate the position of that person any number of ways. We can put in other words, we can put our origin any place we want. One logical place might be to put the origin at one end of the hallway, and let's pretend the hallway is 100 meters. We would have a number line that looks something like this, or a position line that looks something like this, and we can figure out the person's position at any time. But if we look at our drawing here, we start on the negative side of our position versus time graph and end up on the positive side. So it looks like they chose something more like this for the position of their origin. Maybe the center of the hallway. And out here at this end we'd be at plus 50 meters, and down here would be at minus 50 meters. So if a person started over here on the negative side of the origin and was walking to the right, they would start out with negative x values, and as time went on, eventually they'd cross through 0 and end up at positive x values. So it looks to me like they've chosen the origin somewhere in the middle, and the person never turns around and goes back. How do we know that? Because x just increases continuously as time goes on. One thing you might want to do is stop the video right now and draw a graph of position versus time for a student walking down the hallway that stops and turns around and goes back in the opposite direction. So the answer is no to part A, and if they did change directions, the graph would look something like this. The x value would increase, and then it would decrease. And if we looked at two different times, we would find the same x value. So in other words, the person passed through, let's call that x1. The person passed through x1 at time t1, and then turned around and passed back through x1 at time t2. Two different times with the same x coordinate. That's a sure indication that the person changed directions. Now we want to know about the same position. Are they ever at the same position in the hallway at the same time? So since the vertical axis is position versus time, then any point where these two graphs intersect, they're at the same position. So this is at 9 seconds, and this one is at 2 seconds. So there are two times when the students are at the same position at the same time, 2 seconds and 9 seconds, where the graphs intersect. Now we want to know if they ever have the same speed. And what we're looking for, if this is position versus time, then the slope of this graph gives us the speed. Student A is following a straight line path, so any point along that path has the same slope. They are moving at constant speed, but student B, the speed is changing. They are experiencing acceleration, and so we want to know at what point does the slope of the red curve match the slope of the black curve. And it looks to me like it happens somewhere around 6 seconds. Sort of there. We roughly have a tangent line that matches the slope of the other curve. Part D asks if they ever have the same acceleration. Well, student A has 0 acceleration. because the velocity is constant. Sorry, the position is moving, the position is increasing at a steady rate, linearly. Velocity is constant, acceleration is 0. Student B, their velocity is changing. The slope of that curve changes as we move along, so the acceleration is not 0. It has some non-zero value, so therefore they never have the same value. One is 0, one's not 0, so they never have the same value. Now we're looking at a vertical axis of velocity, and we want to know if either one ever changes direction. And the answer is yes. The ones that are negative are moving, so let's just look at student A. Up to t equals 5 seconds, the velocity is negative. After t equals 5 seconds, the velocity is positive. So at t equals 5 seconds, they change direction. They were moving in the negative direction up until 5 seconds, then they're moving in the positive direction. And for student B, at t equals about 6.5 seconds, they change direction. Their velocity goes from negative to positive. For part F, we want to know if they ever have the same velocity, if the vertical axis is velocity. So what are we looking for? The point where those two curves intersect. We've got one point here and one point here. So the answer is yes. At t equals 2 seconds and t equals 9 seconds. And part G is asking if the two children ever have the same acceleration. So if the vertical axis is velocity, acceleration is the slope of these curves. And about t equals 6 seconds, the slope of the red curve and the slope of the black curve match.